Good morning and good day. I am Arvin Godfrey of BSECA33 and I have been tasked to present my activity number 3, which is a 2-digit 7-segment display with 74HC595 using Arduino microcontroller. So let's proceed. So my objectives is or are to simulate the count-up timer from 0 to 99 using two 7-segment displays. So again, two stages. The first stage would be the Arduino codes or the Arduino circuit itself, and the stage 2 would be the circuit's construction and use of 74HC595 with two 7-segment displays. So first, let's begin with the Arduino code. Let's put a breakdown to it. I will show you first. We will run it, and as it is running, I will explain it in the first and how it will function. So first, this is my setup. As you can see, that's a lot. Later, we will discuss that. Next, we have the pin assignment. These are the pin assignments. As you can see, these are a lot. We will proceed later with that. Then the binary data flow. This the data movement. As you can see, these are it. Then lastly, the pin assignment. So with this pin assignment, we can see that the data will be used to present the data, or as you can say, the binary data into the 7-segment display into the decimal form. So as you can see, again, another BCD moment or a BCD input output. So we can see that this is how it is. So next is I will show you how I guided myself in using the 74HT595 with two 7-segment displays. So as you can see, I need to make sure that I understand what each pin is doing and how to use it. So as you can see, the first 7 and the 15th pin is the Q0 to Q7, which are the output pins, the digital output pins. And of course, pin 8 is the ground. Q7 is the serial out, MR, master clear, shift register, storage register, output enable, active low, serial data input, and the positive supply voltage to pin 16. So next to that, this the type of circuit that I will be building, but this only one. So I had to find another way on how to make it so that could connect to the other one. So first of all, I need to build it in a way where I can do it first with just one 7-segment display. Then afterwards, I can connect another one in order to provide a second segment display that will result in being able to show two 7-segment displays working in synchronicity to show the numbers from 0 to 99. So let's go to my circuits construction so that we can have a better idea, and also in my Arduino IDE programmer within my laptop to see how I managed to come up with those. So let's begin first with my circuit in Proteus. So this is my Arduino. There's the reset button. This is the 74HC595. So as we zoom in, I needed to connect the correct pins, the correct input and output pins. So as you can see, I use 2, 3, 4, 5, 2, 3, 4, 5. Number 2 connected to 12, the STCP. And as we can go back, the STCP is the storage register clock pin or the latch pin. So what it needs to do is to prevent it from going upward when it's not necessary. What do I mean? If we're trying to present the number 10 to, let's say, 0 to 9. So the left 0 or the 10 0, it cannot show 19, 29. It cannot do that. So we need to have it latched to prevent that from happening. Then the SHCP shift register clock pin, the changing, the signal that will drive the change towards the 7-segment display in order to go from 0 to 99. Same with the other one, 0 to 99. Then the DS serial data input, again serial in, this the Arduino serial in, parallel out. So as you can see, there's the serial input, there's the parallel output. So there you as we can see, it's really very complicated based on the initial observations. Then the master reset, master reclear, should be active low. So it needs to be derived as well. It needs to have a specific voltage that will drive the MR with using a 10 kilo ohm so that it doesn't short or it doesn't break the circuit because of over being charged too much or providing too much current. So 10 kilo ohms. So that should smooth out in the OE or the ground part. So you can see because there is no number 8 pin here. So you can see it should be number 8 the ground. But here you will ground the output enable. So all the active lows have a specific function there. So again, it should also have the master reclear so that again the data stored here does not get stored for too long. It needs to be cleared because when you're going from 0 to 9, then from 10 to 19, 20 to 29, there needs to be a change there as well. So you cannot we could say overwhelm the micro the 7 segment decoder, so that, because again we're using an Arduino here because it's driving code. It is using the code to create the signals, and when the signals are going into the 7 segment decoder, it should not store too much information to the sense that it will overwhelm. It will fill the information capacity of the 74H7595. So again, because we are dealing with digital data, it needs to be able to present that BCD, the binary coded the binary code, into a decimal output, which is from 0 to 99. So again, there's a reset button. We will use that later. So I didn't use any analog pins. It's all digital pins. And the good thing about using 74H7 HC595, I'm only using 3, or even less than 3, or we could say 4 pins in total. The good thing about that is, again, I can connect the Arduino to the two 7 segment displays. But the problem there is I will have to use multiplexing, and I am not and multiplexing is again a very hard topic to grasp. So rather than using multiplexing, I would rather use the 27H74HC595, which is present in the Proteus. So I might as well discover how to use it. So from there, let's see. Okay, let's check the Arduino code first before we proceed with the simulation. So earlier I shown you the setup, which is the define latch, data, clock, MR, dot, alpha, and lambda. So these are what you can say as let's look at the comments. My signal clock pulse, my data signal, my shift clock pulse. They need to have values. So they are all arbitrary based from the guide that I use. They have a specific specification. So these are the numbers that I use. Then the byte setup. So these are the numbers that I will be manipulating within the code. So these are what would represent my 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, all arbitrary based on the guide. These are the numbers that I should be using. So based from that guide, I use the void setup. So again, pin modes, digital writes. So my MR needs to be low, high. So latch, there should be, I'm going to use the latch, the latch pin, data pin, clock pin, and MR pin. So my setup for the void loop, the float, I'm gonna use the float capacity of the Arduino. So my float will start from zero point 0, and as it is reaching 10, it will slowly increment zero point 0.1 to the float value. So my digital float will be here. This is the value of my digital float, and the delay will be 100. So that, because again it's a lot of numbers, so let's lower the delay a bit. Later we can always change the delay if it's going too fast or too slow. Then we void write letter. Let's set up another function here. So my digital write will be latch, it will be low, shift out, digital write. So again, because I need to understand what this is, I tried to search out what shift out is doing. So this is the description on what my shift out is going to do. So again, we're using a byte, not just a bit, but a byte of data, which will be shifting out one at a time, which will shift the byte 1 bit at a time. So it starts from or I can use either MSB or LSB. So from my presentation, I used MSB first. So again, the CC numbers, again, higher, lower. These are just to separate it. So these are my numbers that I will be using. Again, arbitrary based upon the guide. So my digital write, latch, high. So as you can see, I also searched for what does digital write really mean, what it means. So it writes a high or a low value to a digital pin. So that's the digital write. That's the importance of the digital write. So there's my byte value. Again, modulo 10. I use modulo 10 here because it enables me to properly execute the digital float data. Because if I can use other modulos, but modulo 10 is simpler. It's much more simpler. So that's why I use modulo 10. I can use modulo 2, modulo 5, but I prefer modulo 10 because again, we're dealing with numbers here ranging from 0 to 99, and dividing it by 10 will enable me to make sure that these arbitrary values are actually outputting the correct values. So next, let's proceed. The digital float. So the initial integer position would be -1. So I'm setting up another function here. So character. So this will be what I will be printing out the character value. Then two strings, one for the left, or we could say the tens value, and another string for the ones value. Because again, they're separated. I can't just the thing with this code is it separates the ones value from the tens value. That's why I have two specific strings. So again, this is new for me. So I searched for what DTOSTRF means, and simply just means that what this means is it will convert a float to a character array so that it can be printed easily. Because again, it's hard for the Arduino to be able to show to present to the 74HC595 if I'm using a float value because that's a decimal value. And again, we're dealing with binary values. It's only 0 and 1 or 1 and 0. So this will simplify, again, this will help to simplify the code. So for a two-digit number will be presented in a sense. So the value to 1 character value. Then the integer will be 0, will be, so for this function, I is equal to 0. So the size of the character value, as long as I is less than that, it will slowly increment, to increment upward until it reaches that index of 1, which is 10.0. So proceeding, if it reaches to a certain value, the position will become I. Then afterwards, for integer I, if it is again considering once again what the before that I is equals to 0, I is less than the POS, then again it's incrementing. So for the first one, my alpha string will be adding to the character value. Then same with the lambda string. So from there, you can see that what happens here is the numbers being used here are being again using the computational power of the Arduino. You are solving for the first the very first value up to the very last value. So we're solving 0, we're solving 1, we're solving 2. Then we're assigning that value to the alpha string for the first part and the lambda string for the second part. So for example, we've reached number 9. So we'll proceed to the lambda string, or we've already reached number 19. So we'll proceed to the alpha string. So that's what we are trying to do. So the last part of that function is that once we print it, once we are printing it, because I cannot use the serial print because again we're dealing with a binary decoder, 7 segment decoder, so we cannot print it out. It's not an LCD. So what I need to do is again use digital write, shift out, again focusing on MSB first, MSB first. So for alpha, this what we could consider as when I say they, this is the tens place, and this is the ones place. So this the 0 to 99. Lambda string will be representing 0 to 99, and alpha will be representing the tens. So this will be the 10, the 20, the 20, the 30, the 40. This will be the 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, digital write latch high, so that in a sense, once this reaches 10 up to 19, it will stay there. But afterwards, it will change 20, then onwards latch. So as you can see, that's the value. That's the process. So okay, let's verify. Let's check. Let's check once again. Let's check. Let's edit the properties. Let's see. Okay. So let's get the hex file. Hex hex. So as we are waiting for, so let's see. Okay. So that is available. Again, the message was, as you can see, there's a message here saying there's something wrong. That was earlier because I ran the program without checking first that there was no file. So okay, let's see if my hard work paid off, and let's see if it is functioning, and let's hope it is. Okay. Oh, as we can see, it's functioning. So let's look at it close up. So that's how fast it is changing. So from 0 to 1, again, the code is working. Again, it's a good thing. The code is working. The circuit is working. There's no problems with the wiring. I use different colors so that I am not confused with the wiring. I use different colors so that to make sure that my eyes are not making mistakes in making sure that the two 7 segments are properly wired. Because again, there's always going to be a problem with wiring. There's going to be a problem with the code. Could be a problem with the Proteus itself. And as you can see, it's working. It's working as intended. So 99.0. So let's press the reset button. So as you can see, it's resetting. Again, it's due to the code. So since it's going a little bit fast, we can always slow it down. So let's try to modify some parts of the code. And the important part to modify, as you can see, there was a delay earlier. That delay was here. So we can slow it down if you want. Let's try 200. delay it to 100. Verify it. Okay. This was very hard. I had to use different guides to make sure that I know what I'm doing. Okay, let's proceed. Check. Oh, see. Okay, edit the property. Program files. Okay, let's do it again. So again, a little bit slower. See? So there's delay. So that's the delay. It's twice as slow as the last one, which is still fast, but twice as slow. So as you can see, there's a problem with my Proteus. It's lagging. That's why it's not showing it quickly. It's going back to 8. So there. You see, it's not really. It's very difficult as well as you can see. The challenges that this two-digit 7 segment display provided for me. But still, it's working. It's functioning as intended. So let's go a little bit faster. Let's try 70. Let's go back to the original value. Because again, we're testing it 3 times to make sure that it's functioning well. It's functioning according to specs. So let's go to the next file. Okay, let's test it again. See if it goes back to the original speed. Okay, that's the original speed. As you can see, it's functioning as intended. No lag, no problems whatsoever. And from there, we shall end the simulation. Again, thank you once again for listening, and I hope you have a great day.